So in our last lesson, we looked at, I introduced you to the concept of limiting reactant. So the last thing we ended on was how do we find the limiting reactant? So you already have this copy down, but what we said you have to do is you convert each reactant to moles of the same product. Always use the first product. The reactant that produces the least amount of moles is your limiting reactant. All other reactants are excess reactants. So let's look at some actual examples. So here we have a chemical reaction. SiO2 plus HF yields SiF4 and H2O. So we do need to balance our equation. So let's check on this. So we're going to put a 4 here. That's going to give me 4 fluorines and 4 fluorines. That gives me 4 hydrogens. So let's put a 2 here. 2 times 2 is 4 hydrogens. So we have 1 silicon and 1 silicon. And we have 2 oxygens and 2 oxygens. So 1, 4, 1, 2 will balance that equation. So the question says, if 2 grams of HF is combined with 4.5 grams of SiO2, the other reactant, notice these are the only 2 reactants, there's 2 reactants. And what we're trying to do is figure out who the limiting reactant is. So we're trying to figure out which one of these is going to run out first. Want to know which is the limiting reactant and which is the excess reactant. So let's follow those steps. We're going to convert each reactant to moles of the first product. So these are both our products, but this is the first product. So we're going to convert to moles of SiF4. So let's do that. 2.0 grams of HF. And we're going to go to moles of SiF4. And the other reactant was 4.5 grams of SiO2. And again, we're going to moles of the first product, so moles of SiF4. All right, now let's think about the calculations we've focused on this week. Grams of A to moles of B. This is a 2-step conversion. So this is where you have to be able to determine at this point how many steps it is. Well, gram to mole, mass to mole, and mole to mass calculations are always 2 steps. So this is a 2-step conversion here. So let's get this units to cancel. We need grams of HF on bottom. That means this is our molar mass. And so let's figure out the molar mass of HF. So I'm going to come to the side and we have hydrogen and fluorine. Of course, hydrogen is 1.01, fluorine is 19.00, and that's going to give you 20.01 grams per mole for the HF. So we're going to plug that in here, 20.01 grams of HF. Now remember, molar mass is always grams per 1 mole. Now we need moles of HF to cancel, so we're going to put moles of HF on bottom, and we're going to put moles of what we're trying to find on top, which in this case is silicon tetrafluoride. This is our mole bridge, so these numbers, remember, come straight from the balanced equation. So we have 1 SiF4 and 4 HFs. So it's a 1 to 4 ratio. So let's plug that in. We're going to say 2 divided by 20.01 divided by 4. And this needs to be 2 sig figs. So what I get for that, and y'all need to make sure you plug it in 2 to verify that you are getting the same numbers that I'm getting, but I get 0.025 moles of SiF4. Now let's do the same thing with the other reactant. So we need grams of SiO2 to cancel. 1 mole of SiO2 on top. So we're going to go to our periodic table and we are going to figure out the molar mass of this. So from the periodic table, the silicon is 28.09. So I'm going to come over here and do the Si. That's 28.09. And again, please look at your periodic table and make sure that you're following along. And then we have O2. So there's 2 oxygens times 16 apiece. So 2 times 16 is 32.00. So we're going to add that together. So that gives me 60.09 grams per mole for the molar mass of the silicon dioxide. So 60.09. Now, this lets grams of SiO2 divide out. So now we need moles of SiO2 to cancel. So that's going to go on bottom because you need your units to cancel. Again, always watch your units. And we're going to have moles of SiF4 on top. This is a mole ratio again. So let's look up. SiF4 was a 1, and the SiO2 was also a 1. So it's just a 1-to-1 ratio. So you're going to plug in 4.5. So again, plug this in, divided by 60.09. And for that one, we need 2 C-figs also. So when I plug that in, I get 0.075 moles. Now, let's think about what we did in the sandwich example and what we're going to do now, because it's the same train of thought. So when you get to this point, you figure out how many moles of the first product you can make. Whichever one makes the least amount is your limiting reactant. Remember the sandwich example? The sandwiches, the peanut butter could only make 35 sandwiches. That was the least amount. So whichever one makes the least amount is your LR. Well, the limiting reactant will run out when only 0.025 moles of the silicon tetrafluoride have been made. So this is our least amount. So that means that the limiting reactant is the HF. So you got to make sure that you are very careful about how you identify. The limiting reactant is the HF. It is the reactant that ran out first. There's 2 reactants here. The HF will run out once I've made 0.025 moles of SiF4. So that means there's going to be some excess of the silicon dioxide left over. So the excess reactant, so excess, is the SiO2. Kind of bubble those in so they stand out. So that's our first example of finding the limiting reactant. Let's look at another example. So here we have N2H4 plus H2O2 yields N2 plus H2O. So let's see about balancing this equation. So here we have a total 2 nitrogens and 2 nitrogens. On this side, we have a total 4, 5, 6 hydrogens. So we need to get 6 hydrogens over here. So let's see. But I also have 2 oxygens here and 1 oxygen here. So I may want to think a little bit about getting those. So let's try putting a 2 here and see how this does. That's going to give me 4 hydrogens here plus these 4. That's going to give me 8 hydrogens. So if I put a 4 here, 4 times 2 is 8. That gives me 4 oxygens, and 2 times 2 is 4. So I think that balances it. 1, 2, 1, 4 balances that equation. So let's look at 2A and then 2B. So this is really more like how the limiting reactant problems will look, where you'll have a part A and a part B. And in part A, you're going to be asked to figure out who the LR and excess reactants are. And then in part B, you're going to be asked to do something with that number. So here we have, it says if 0.750 moles of N2H4 reacts with 0.500 moles of H2O2, which is the LR and which is the excess. So again, these are our reactants. We're trying to figure out which of these 2 reactants will run out first. So let's convert each of them to moles of the first product. Now the first product is nitrogen. We're going to go to moles of the nitrogen. So again, let me rebalance this since this was a 4. I did not mean to erase all of the ink on that slide, but I did. Okay, so we had to put a 4 here. That gave me 4. No, we said it was a 2. Hold on. Okay. So we put a 2 here, and that gave me 4, 8. So we put a 4 here. That gave me 4 and 4. Okay, so that was, it was a 1, 2, 1, 4 is what we got with that one. So we're going to start with 0.750 moles of N2H4. And we're going to take the 0.500 moles of the H2O2. Now remember, to figure out who the LR is, you're going to convert to moles of the first product. So this is our first product right here, first product. So that's what we're going to go to moles of. So we're going to go to moles of N2. Moles of N2. All right, mole of A to mole of B. Let's think about this. How many steps is a mole to mole calculation? Well, those are only one step, so this will be short and sweet. So we're going to put moles of N2H4 on the bottom because we need moles of that to cancel. And we need moles of nitrogen on top because that's what we're looking for. So this is, again, is our mole bridge. It comes from the balanced equation. So the N2 has a 1 and the N2H4 also has a 1. So that's a 1-to-1 ratio. So we get 0.750 moles of nitrogen. Let's do the same thing with the H2O2, which is hydrogen peroxide. So let's put moles of H2O2 on bottom and moles of nitrogen on top. So we're going to put our numbers from the balanced equation in next. So let's look up to our balanced equation. And the nitrogen has a 1, so 1 mole of nitrogen. And for the H2O2, we have a 2. So we have 0.5 divided by 2, and that's going to give me 0.250 moles of nitrogen. So at this point, whichever one makes the least, and this is the least amount is our limiting reactant. So you would say that the limiting reactant is the H2O2, and the excess reactant is the N2H4, the other reactant. Okay. Now, part B. So it says how many moles of water are going to be able to form? How many moles of water are going to be able to form? Well, remember, we said the limiting reactant is the thing that controls how much product you can make. So if you want to know how many moles of water will form, you have to start with the limiting reactant. We just figured out in part A that the limiting reactant was the H2O2. So we're going to start with the amount of the H2O2 that we were given in part 2A. So remember, from part 2A, we were told that we have 0.500 moles of H2O2. That's what you're going to start with down here. Start with your moles of the limiting reactant that you had from part A of the problem. So we're going to start with 0.500 moles of H2O2. And we want to go to moles of water. So it's asking us to find the moles of water. How much water can we make? Mole to mole is one step. So I'm going to put moles on bottom of H2O2. And on top, I'm going to put moles of H2O. Let's look at our balanced equation. The water, H2O, has a 4. So it's a 4 ratio. To the H2O2 has a 2 ratio. Notice the moles of the H2O2 will cancel out. So we have 0.5 times 4, which is 2, divided by 2, which is 1. And we need 3 sig figs. So 1.00 moles of water will form. Now y'all plug that in and make sure you get the same answer as I did. All right. Let's look at another example. So here we see Zn plus S8 yields ZnS. So let's balance this. We're going to need to start by putting an 8 in front of the zinc sulfide, and that gives us 8 sulfurs. That also gives us 8 zincs, so we're going to put an 8 here. So 818 will balance that equation. So this one says if 2 moles of zinc are heated with 1 mole of S8, which is the LR and which is the excess? So we're going to convert to moles of the first product. Well, this only has one product, so we're going to go to moles of ZnS. Start with your givens. 2.00 moles of zinc. And we're going to moles of ZnS. And we're going to start with 1.00 moles of S8. And we're going to convert that to moles of ZnS. All right, let's get our units to cancel. Moles of zinc needs to cancel, so we're going to put moles of zinc on bottom. We're trying to convert that to moles of ZnS, so that goes on top. The ZnS has an 8, and the zinc also has an 8. Again, this is a one-step multimole problem. Moles of zinc cancel. You'll notice here the 8 and the 8 reduce out. You can simplify this. So we end up getting 2.00 moles for that part. Let's do the same with the sulfur. So we need to get moles of S8 on bottom, and we need moles of ZnS on top. Let's go back up to the balanced equation and get our mole bridge. ZnS has an 8, so we're going to put an 8 here. And the sulfur has a 1, so we're going to put a 1 here. So we have 1 times 8, and that's going to give us 8.00 moles of ZnS. So when we get to this point in the calculation, the one that makes the least amount is our limiting reactant, and of course our least amount is 2. 2 is less than 8, so that means that the limiting reactant is the zinc, and the excess reactant is the S8. The limiting reactant is the zinc, and the excess reactant is the S8. All right, let's go to part B. What mass, remember mass is grams, of ZnS can be produced? Now recall that the limiting reactant is what determines how much product you can make. So if it wants to know what mass of ZnS can be produced, then you're going to have to start with your limiting reactant. And remember, we just found that in part A. So we figured out in part A that the limiting reactant was zinc. So let's look and see how much zinc they told us we had. In the problem, it said we had 2 moles of zinc. So that's going to be what you start with. 2.00 moles of zinc. And it wants us to go to mass of ZnS. So we're going to go to grams of ZnS. Mole to gram. This is a 2-step conversion. So you're going to need moles of zinc on bottom because you need that to cancel out. And since this starts with moles, that means the mole bridge comes first. So we're going to put moles and moles of B. And B is who you're trying to convert to, so it's moles of ZnS. So look up at your balanced equation. Remember, that was an 8 to 8 ratio. So 8 over 8. That's going to let moles of zinc divide out. Now, we need moles of ZnS to cancel. And we're going to need grams of ZnS on top. So this is our molar mass, grams per 1 mole. So we got to add up the molar mass of ZnS. Now, if you look at your periodic table, find zinc. From the periodic table, that's 65.39. So I'm going to add that here, 65.39 for the zinc. And then the sulfur is 32.07. Let's add that together. 65.39 plus 32.07, and I got 97.46 grams per mole. So that is our molar mass of that compound. So let's plug that in here where our molar mass goes, 97.46. All right, this is going to let moles of ZnS cancel. So we have 2 times 8 times 97.46. And then we're going to divide that by 8. And we need 3 significant figures, so that's going to give you 195 grams of ZnS. 195 grams of ZNS. In our next lesson, we will learn about percent yield.